Today, Open Source Security is talking to Dimitri Stiliadis, the co-founder and CTO of Endor Labs. Dimitri, welcome to the show.
Thanks for having me, Josh.
Oh, I'm so excited to have you here. So Dimitri's going to talk to us today about the TJ Actions changed files, I guess backdoor malware insertion. I'm not sure exactly what to call it, but Endor Labs has a blog post I will put in the show notes that talks about this action. And I guess the craziest part of it is it is a bad malware that happened, a bad backdoor, but your folks did the research and it only affected 200, I guess, repos, which is like a shockingly small number.
Actually, I think we, as an industry, right, as a community, we got lucky. It was discovered within hours, thanks to the work by the Step Security guys, right? So it was discovered, maybe within 24 hours or whatever. So it didn't propagate a lot. Having said that, it's first of all, it's very concerning because we don't know how many other of these things are happening, right? And when you actually go back and see at the forensics of this thing and what happened before, and several people did some work, we can talk about it. It was a very targeted attack potentially, and it took a very long time. It is something that they were planning for several months. So that's why these things are really scary here.
Yeah. Okay, so let's just start with what are we even talking about for anyone who maybe doesn't know? What is the TJ Actions change files backdoor?
Right. So let's start from the end, probably, before we go to the beginning. So TJ Actions is a public GitHub action. Right, it's used by anybody or by people that have chosen to rely on GitHub Actions for their CI/CD pipelines. So what it does, it's actually a very simple thing. It goes and looks if a particular PR has changed some files. Right, so that's what is the action. So it's very popular, right? And what happened is, somebody, through a malicious intent, they managed to insert there some malware that would get all the secrets out of the CI/CD pipeline, and it would spit them out as a log message. And so if you have a public repository that is using this action, potentially all the secrets of the CI/CD pipeline, they would show up in the log messages that are also public. So anybody now that has access to the internet could go and see the logs, and from the logs they could see the secrets, right? So it's like publicizing to the world the secrets of CI/CD pipelines, right? So who gets immediately affected is the immediate impact is anybody that has an open source repo that is using TJ Actions, and it happened that the CI/CD pipeline ran in the window that the TJ Actions was infected, let's say. Their secrets were out on the public to see, right? So that's the main impact. Now, where we got lucky is that because it was discovered very fast, it was discovered within 24 hours, GitHub immediately pulled the code out, so it was not accessible. And only a small set of pipelines ran and exposed their secrets. So even though the potential targets were in the thousands, we did some research and we found that only about 300 of them were actually run and exposed some things. And in most cases, they didn't really expose a lot of stuff. So we got lucky, right? Luck was on our side. Now we can go and discuss about what the impact could have been, but thankfully we got lucky.
I mean, I feel like we got lucky is how a lot of these stories seem to end, which thank goodness.
Yes, it's like we got lucky also with the XZ attack several months ago because some, guy with OCD, I would say, I don't know, discovered that something was running 200 milliseconds slower than what it was running, right? That's again, we got lucky there. But in this particular case, I think we got lucky. And that's why we didn't have bigger impacts, right? Because, the way I see it is what could be an impact, right? And, we have to understand how these things propagate. That assuming that somebody in their repository was pushing in a CI/CD pipeline, let's say, an artifact to Docker, and they had Docker secrets there, and the Docker secrets were exposed, then somebody would get these Docker secrets and they could override this artifact and they could do all kinds of other damage, and then it would propagate even more and stuff like that, right? We live in a world where all these things are so interconnected that the bad guys have figured out that by attacking the CI/CD pipelines, they can amplify the effects of the attack very fast and reach out to additional places, right? That's the critical part of this equation.
So I think there's another piece of this that I find so interesting is I feel like have this focus on the artifact we release, right? Where that's what a lot of people scan. It's what we worry about the vulnerabilities in. But it feels like the CI/CD, the build systems are what keep getting attacked here.
Yes. So this is a pattern that has started, I think, several years ago. And the frustrating part for me is, to be honest, if I want to vent a little bit, that we're doing nothing about it, right? So
yes,
if you remember, that was 2-3 years ago. It started with CodeCav, right?
Yep.
This happened almost 3 years ago, right? That some bad guy went and found a way to change an artifact that CodeCav was doing. And then people in their CI/CD pipelines, they were just downloading this artifact, no checks about checksums or whatever, using it. This exposed a whole bunch of secrets. It sent a whole bunch of secrets to the bad guys. Then it happened again, and it happened again. It happened with the XZ attack. It happened with this thing. And we have to take a step back and say, first of all of the things that led to this are well known. And I want to talk a little bit about, because some other people did a very good analysis. The guys from Unit 42 at Palo Alto Networks did a very deep analysis of how this attack happened. And the root causes are things we know. In all cases, the root causes are things we know. And despite knowing about them, we are doing nothing about them. And that's the frustrating part.
So can you explain the kind of the how we got there part? I'm not as familiar with that as I am with kind of what you talked about in your post.
Yeah, so I talked a little bit about, but again, I will give credit to the Unit 42 guys, because they went back to figure out the whole chain, right? So, and it's mind-blowing how the whole chain. Apparently, the whole thing started in November of 2024, where the bad guys noticed there is this very well-used, actually, open source software called Spotbugs in Java, right? That is doing static analysis against Java targets. So what they noticed is that in the Spotbugs repository, if they would do a PR against this repository, the PR would run the CI/CD pipeline. And by doing that, they found actually that one of the maintainers of Spotbugs had put in the CI/CD pipeline a personal access token, a PAT from GitHub. So they used this trick to steal the PAT. Okay, so they got the PAT of this maintainer. Then they found that this maintainer was also maintainer in another project. And they went to this other project, and by using this PAT, they did a commit that allowed them now to change a GitHub action in this other project. Now, this other project was part of was being used by TJ Actions. So then they went to TJ Actions, and by following the train now, they found a way to manipulate the TJ Actions and do a commit there and change the tags. And so what they did essentially is they pretended that what TJ Actions, let's say, was commit number, I don't remember the exact name, but if it was a tag 1 to 2.3, instead of pointing to a valid commit, it was pointing to an invalid commit, right? So they essentially used 3 or 4 levels of steps to go from finding some exposure somewhere, stealing one token from there, going to the next repo, go to the next repo, and so on. And in theory, right, according to at least the Unit 42 report, they had an ultimate target that was a Coinbase repository.
Oh, I see.
Okay? Now, was that the ultimate target? I don't know, right? It might have been another 20 of them that we don't know about, right? But you see the sophistication of this thing now, right? That somebody was hunting it for several months. They started from November and they ended up in this space in March, right? So they were working for several months on this, right? So we're talking about a very sophisticated attack at this point. And they took advantage of some specific things that we know about, right? So what did they take advantage? The first thing they took advantage is that it is well known there are several reports on the internet that if you are using GitHub Actions for open source repositories and you allow your CI/CD pipeline to run against a PR, you have to make sure that this PR has very limited privileges because otherwise anybody that does a bad PR against your repo can potentially manipulate the whole situation, right? So this is something we knew. We know it. People have alerted for it for years. Nevertheless, it's still out there. The second thing they took advantage of is never put personal access tokens, especially personal access tokens with privileges across a lot of things, as secrets on a GitHub action, right? We know that, right? It's like people steal secrets all the time. We know that. Never do that, right? Again, we know that. Nevertheless, we did that, right? The next thing we knew about is when you use GitHub Actions, don't just use tags, but pin them to a specific checksum.
Yeah.
We know about it. Nobody does it. So these are all things we know about and we don't do anything about. That's why it's frustrating.
So it is frustrating. I'm hesitant to say we know about it and we don't do anything about it. I actually talked on the show to a gentleman named Francois Prue. It's been a couple months now, I think, but he does a lot of work with CI/CD and build systems. And kind of the thing we talked about a lot is the fact that if these aren't default options, like if you don't make people pin an action to, a checksum, most people don't do it. And some are lazy and just forget. Or, I mean, I know I'm notorious for, I'll fix it later. And I mean, there's a joke I know in the machinist industry that there's nothing more permanent than a temporary fix, which is true of IT.
You are absolutely right? So the lack of secure defaults in all these operations, I think this is what is leading to this situation over and over again. And maybe we can blame GitHub a little bit here, because on their effort to make these things as friendly as possible to developers, they are sacrificing the secure defaults, right? So let's go from the beginning, right? So GitHub could make it a default that if you have an open source repository and you do a PR, you're not going to run. You cannot run with any sensitive privileges, right? They could stop there, then and there, right? They could make it a default that you cannot have a path as part of the secrets because that creates a problem, right? But this would create tremendous friction from people using it, and that's the fight. That's the if you want the back and forth we're always going between security and usability, right? That if it creates friction and the system is not used, it's secure, but it's not used by anybody, right? So I think that's the struggle that we have, that the lack of secure defaults are usually there for making it more user-friendly.
Yeah. For sure.
Right.
Okay, I want to steer us into your research before we run ourselves out of time and complain about CI systems too much, because goodness knows, we'll have you back someday. We could just spend an hour complaining. But I want to talk about, so I read your report, and there were, 5,000, I think, runs by the malicious action, around 200 catalog secrets. And I feel like there's two sides of me when I read this. There's the side of me that thinks, only 200, that's not very many. And then there's the kind of the other side of me that's like 200 is a lot of things that were affected. And then I don't know. I mean, what did your crew do when they found those 200? Like, did they start filing bugs? Did they reach out? What
Yeah, I
happened
mean,
then?
we reached out to and that's why we're careful, right? So when you do this type of things, first of all, I think people mostly have heard, right? Because it got a lot of publicity, but we reached out to the 200, to the maintainers, right? And notified them about it. And, we didn't publicize who are the 200 and so on. And, the process was pretty simple and straightforward, right? You just go to the GitHub APIs and start, ingesting the data and analyzing the data and so on. Now, I think in most cases, what leaked were secrets that were ephemeral, and that's the good news about the 200, right? In very few cases, they were, I saw some secrets with GovCloud, for example, over there.
Oh.
Right? They were named GovCloud. Now, were they GovCloud? Were they not GovCloud? I have no idea, right? But
Wow.
it's like, you would see AWS credentials, you would see Docker Hub credentials, you would see all kinds of things, right? So now, in most cases, it was not alarming. Again, I think if it was not discovered within 24 hours, it would have been thousands of them.
Yeah.
I think that's the trick here, right? And I think the fact that GitHub, the moment that it was discovered, GitHub went and withdrew the action, right? It was not accessible. So when they did that, they actually broke a whole bunch of CI/CD pipelines.
Yep.
Right? And so they took the hit of breaking a whole bunch of CI/CD pipelines because the consequences of these things could be dramatic, right? Because again, it's a chain of things that happening, right? Because what the bad guys are looking is, I'm going to get the secret from this, and then I'm going to use the secret to go to the other place and get another secret and get another secret, right? It's the chain that is very concerning, right? So what our team did is use the GitHub APIs, figure out everything that was using GitHub Actions, went and saw if there were CI/CD runs, look at the CI/CD runs, did they expose the secrets? If they exposed the secrets, alerted them. And, that's what you have to do as a good citizen of this community, right?
Yeah, for sure. And I applaud Endor for doing that, because I have done an enormous number of disclosures in the past. And anytime you go above like 5, it becomes a lot of work.
Yeah, I mean, in this case, right, we notify the maintainers, right? That's where it went, right? At least we didn't have to issue a CV or something for every one of them.
That's true. That's true. That's a whole other story. But
that's a whole other story.
So I want to talk about this whole like getting lucky aspect, because I feel like we've gotten lucky with a lot of open source things. And part of me wonders, are we getting lucky, or is this just how open source works? And I can't decide which. I mean, I don't like either necessarily, but, I wonder this.
So here is a good question, right? So think if the same thing had happened to a closed source repository, then we wouldn't even know about
That's
it, right? So it is a curse and a blessing at the same time, right? The fact that if this was not such a widely used GitHub action, right? And potentially there are tons of them that are not widely used. And it is used by some whatever, target, whatever. And it was not discovered, right? And by the way, they can exist out there. So I actually think that open source helps us to discover these things much faster than, and actually open source that is widely used helps us discover these things much faster than the closed source things, or potentially open source that is not so widely used, right? The key, I think, is more the widely used rather than the open source.
Yeah, that's fair. I won't argue with that. And I mean, you can also make the argument like closed source application, while we might never know if it gets attacked, it also, the fact that there was an open source supply chain is how we got there in the first place, because they attacked the first thing way over there, which was open source, and then, followed the open source all the way in.
Right. Because, again, we have example about supply chain attack in closed source systems like the SolarWinds incident, right?
Yeah.
That, again, several years ago, it has much bigger impact. And most concerning is sometimes I get in this doom and gloom situation in my head. Most concerning is that we really don't know how many other thousands of things are in this state, right? Again, with the two examples we have, both the XC attack and the TJ Actions incident, right? They were very widely used open source components.
Yes.
Right? And then we can talk also about vulnerabilities, right? Because, I constantly do this observation, because vulnerabilities is another issue of this, right? I think there are, 6,000 reported vulnerabilities on Java packages, some number like that.
It's probably
under
more
10,000.
than that, I bet.
Maybe. I think if you go to ASV.dev, right, they have like 6,000, maybe 10,000.
Okay.
I don't remember the exact number, right? There are more than 5 million Java packages.
Yes.
Okay. So do we really believe that the other 4,990,000 are squeaky clean? No, we just don't know about it.
No, for sure. And so the example I always use for this is you can go to GitHub search and type buffer overflow in, and you get millions of hits. So we have 250, there's I think like 290,000 CVEs total at this moment in time.
Right.
So we're missing a couple of things, for sure.
Yeah,
sure.
We are missing. So, but in any case, right? So I think though that by having a community, by having something that is very popular, it's very likely these things will get caught, right? That's the trick.
Yeah, for sure.
Right.
Okay, I want to talk about another piece to this though as well, and this goes back to kind of the CI angle. Is I feel like we have no insights into our CI systems. Like my example being, there are, without question, organizations that have no idea what is running in their CI systems because they just popped in some action. The intern did it 5 years ago and no one's paid attention since. And they're like, we don't know what this does, but we can't remove it. So whatever. And it's mind-boggling sometimes, right?
So, and I will focus on two areas there, right? The one is the first thing that we don't even realize is that this GitHub Action, it's just GitHub Actions. I think it happens even on Jenkins servers or whatever, right? These open source helpers, right? First of all, they have transitive dependencies the same way that open source packages, right? So an action depends on another action that depends on another action. And by the way, this was used in this particular attack, right? This transitive dependency thing was used in this attack, right? So first of all, there is no visibility about this, the whole transitive nature of the software and how interconnected it is. The second thing that I think it's very important that we start understanding is that very often we treat CI/CD systems or these developer pipelines as dev systems.
Yes.
Right? And we tend to go down the path, it's just a dev system. We don't need the same security controls, blah, 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 blah. In reality, we have to recognize that they are the most critical production systems that we have. And we have to apply the same security and controls as we have in our production systems, even if not more strict security controls to our dev systems rather than our production systems, because everything we have in production is coming from one of these systems, right? So I think this mentality, and I think this is a matter of education. It's a matter of us talking about it more and more for people to realize it, right? And sometimes I laugh because, you go do one of these compliance checks, whatever, SOC, whatever, blah, blah, blah. Everybody focuses on the production systems. Nobody's forcing people to look at their dev systems, right? And how is this whole software pipeline has been made? And I think we need to create awareness about it, right? That's my number one goal over here. Right? That's why I'm talking to you. Like, let's make our dev systems production grade.
Yes, I mean, I agree. So I have a marvelous example, actually. I just did a webinar for work last week, and TJ Actions change files was one of the things I was talking about. And so something I did is, so, I work at Anchor. We do Sift and Gripe. Sift is the SBOM scanner. I created a GitHub Action just in a demo repo. I installed the TJ Actions change files. It was a fixed version because, the bad version's gone. But I just told Sift, like, scan the whole frickin' machine. Just point at Sift at / and let it go to town. And it was mind-boggling how much stuff is in those action runners. Like, it is now, granted, GitHub documents this. It's not like they're hiding any of this, but like there's 6 versions of Python. I mean, it's wild how big these things are.
Yeah. And let's think again why they are doing it, right? This is the thing, right? They are doing it because they know that somebody that runs actions, right? And I have seen this container, right? I mean, it's I urge you to go see how this action containers is being built. In several places, they do not even check some calculations, right? So they do it because in order to make it usable, somebody wants this Python version, somebody wants this Ruby version, somebody wants this, I don't know, pick your poison version. And in order to make it usable, these containers are like 20 gigabytes and they include so much stuff there that you have no idea what they are. And, it's against this fight of we're going to make it usable and easy to use. And it's a dev environment. So who cares? I think that's the mentality we need to change, right? No, it's a dev environment, so we need to lock it down as much as we can, because otherwise, who knows what's going to happen?
Yeah, for sure. And I think we can start having these discussions now. I will say this feels very parallel to me of just software development from, let's say, 10 years ago, where people had systems, virtual machines, bare metal, whatever, there's kind of pre-containers catching on, where it was just kitchen sink, right? Because some person SSH'd in at some point and installed a bunch of stuff and no one knew what it was. And they're like, oh, we don't know why that's there, but if we delete it, it breaks. So we just don't worry about it. I mean, I remember these days, like, it was nuts.
I mean, look, I mean, that's the thing we need to recognize, right? That the way we're building these CI/CD systems, we are treating them, there is the old story, right? If you find a USB stick on the parking lot, don't plug it in your computer, but we are just plugging, random stuff in that, it's who knows where they came from. And I always refer back to this. For me, it's one of the key papers, if you want, that describe it. There is this old paper by Ken Thompson, right? The Trusting Trust.
Yep.
Right. I think this has to become like one of these things that we give to every CI/CD owner to read before they can touch the CI/CD pipeline.
When did he write that? He wrote that in like the 80s, right?
In the 80s, right? I mean, it's like talking about predicting the future, right? And we just have to, I think it's a matter of education, right? I think at this point it's a matter of education. And I don't want, when you're going to start using the terms of this month, now imagine how many people are going to plug in random MCP servers.
Oh, I know, right? For sure.
Right? So wait to see what's going to happen over the next year now with AI-generated MCP servers in the CI/CD pipelines.
I know. I think about that every day. Anyway. Okay, Dimitri, we're coming to the end, and I want to maybe I would like to get your opinion on a thought I've had through our conversation. So we talk about education, and I agree. I think step one of any problem is like, what is the problem, right? What is the problem we're trying to solve? And it's easy to say, oh, everyone should understand this, but they don't. And I also think one of the things I think security did a very bad job of, let's say 10, 20 years ago, is talking to the right people. Because we just yelled at everybody. And then everybody was like, these people are a bunch of idiots. We're just not going to talk to them. And I feel like talking to developers directly at this point is probably not particularly helpful because, well, they're developing, they're doing their thing. However, when we talk about things like secure defaults, that is a different group, right? If you talk to the people running and managing and dealing with the CI systems, that's an audience we can probably have a little sway with and we can have a reasonable conversation with because now we've confined our scope. I'm curious your thoughts on kind of what should we do next? Does that make sense or am I off my rocker here?
I understand, right? And obviously, clearly, the people who are running the CI/CD systems have a lot of say over there. But honestly, I have a personal view that I think first time I wrote a blog about it was almost 8 or 10 years ago.
Nice.
I think we have an incentive problem, right?
Ah, yes.
So a developer or a DevOps person or whatever is not going to get a bonus by delaying a release by a month because they are trying to make the CI/CD pipeline more secure. Right? They will get a bonus by, shipping features faster. And the friction between usability and security is often something decided by a different group, right? It's a product manager that often decides or whatever, right? It's the business side of the house, right? And the incentives are just not there, right? And it's unclear how we are going to create these incentives, right? Because honestly, I believe that most engineers want to produce very good quality and secure code.
Yes.
But they just don't have, they have the opposite pressure, right? Their pressure is ship fast, their pressure is not quality.
For sure.
Right? And somehow and if you think about it, a lot of the security incentives are coming from compliance reasons.
Yes, I agree.
Right? And so at some point, maybe what is needed is for compliance to understand also that, hey, these dev environments are very critical. I mean, it's going to take time, right? But I just don't think just talking to people is going to make a difference.
That's well, kind of, right? We have to get the compliance standards to understand what this problem even is.
Correct.
And so that's part of the story. But I agree with you. I think compliance has been a driver of a lot of this. And this is where it feels like today, as part of any compliance program, you have to submit like vulnerability scans of your production systems of whatever you're doing. And it feels like if you had to start submitting vulnerability scans for your build system and your CI system, well, first of all, it'd be a bloodbath. But secondly, it definitely would, I think, raise some eyebrows and get some attention for sure.
Exactly.
Holy crap, what a good ending. I just want to commend you because I feel like often we have these security discussions and we get to the end and it's like, everything is terrible. I feel worse than when we started talking. But no, I agree. I think you make a lot of sense and this feels approachable. So that's awesome.
Thanks, Josh. It was fun.
It was fun. Thank you so much, Dimitri. I truly appreciate the time.
Thanks.